All right, okay. So we're going to start and we're going to talk about what is machine learning. I'm just going to play this PPT. You can see what is machine learning. It's just like a binary solo of of a wrapper. Like all the binary numbers. That is what it is because a machine can only understand binary, just like a wrapper will only understand wraps or rhymes. Okay, not a very good analogy, but let's move on. No, so what exactly happens in machine learning is like a machine or a computer would actually convert everything into numerals because eventually it has to understand binary. So it doesn't matter what data you give it, like digits, numerals, salaries, names, text, or other languages, English, Arabic, French, anything. Everything has a code. The ASCII codes as every variable or alphabet, and then it converts basically into binary. So that's what it does. So if you talk about, there is like a list of words where it has to create its own meaning. It will convert those into numerals and perform some calculations. That some calculations I'm going to define as we move on to this video. And what exactly happens in machine learning? Let's not just not talk about calculation because a calculator can also do calculations. So when you talk about machine learning, it's like adjusting a graph. If you have like a y is equal to x graph, that is on the y-axis and the x-axis goes straight ahead, and you have plotted that graph on the basis of the data that you have, that is distributed equally amongst the line, or more uh, with priority. So now what happens if let's say that data is the amount of rainfall in Mumbai in 2019, sorry, 2018, and now when we record 2019, the data will increase and there will be more points on the graph, and just as we put more points, that's how we'll have to shift our line. So this line, when we talk about shifting our line, this is basically machine learning, where it will learn through the data. So this is not going to change anything. It's not going to be the Terminator rise of the machines, because there's nothing like that sort is going to happen, because it's the data that you feed. It will learn and it will modify and it will analyze itself. Okay. All right, excuse me. So let's talk about pattern recognition. When we talk about machine learning, it has to predict something. So it has to make sense of something that has been said to it, and give you an clearer idea, like listening to an instruction or identifying an intent from what you're saying. So if I say turn off the light, the intent would be turning off, and the entity would be the light. So something like that. So let's take a very basic example where we see this is an array. There are two arrays here. Let's call the x and y. And as you can see from what is on the screen, 2x minus 1 is the relationship. So if I say x is minus 1, then 2x minus 1 becomes minus 3. If x is 4, 2x minus becomes 7. So now what I have is a very small piece of code which will help the machine, this MacBook, to understand what exactly, how can I come to this conclusion that is given in the third line. So let's go back to this code. So this is the Python script. This is idle, yeah. So that is what it is using, and I'm also using TensorFlow and Panda. So this entire code, this is all written in Python. I will explain each and everything in a separate video. There's not enough time to do that in this one. So let us see this. When I run this particular code, you can see bits and pieces of it. The model.fit is basically where we train our data, and to predict is the array that I'm going to pass, and I'm calling that model.predict method with this array, right? So, and also you can epochs. Epochs is the time, how many times or how many iterations you want this to perform, how many times you want that particular machine to learn. So if you can see now, if I had given 10, 11, 12 and 13, so depending on from what our relationship was, like that was 2x minus 1. So if say 10, so it should be 21. Sorry, 19. 2x minus 1, 22 into 10, 20 minus 1, 19. And 11 would be 21, yeah, sorry. and 12 would be 23, and 13 would be 25. Now when we see this result here in this idle portion, you can see basically that's what it is saying. It is saying this is the exact, almost very near values, and in very less amount of data it has been able to predict these values. So this is basically what machine learning is. I can send you this code. You can run it on your own machine. You just have to install Python. If you have a MacBook, Python is already installed. If you don't have a MacBook, then you'll have to install Python. Or at the moment you install idle, it will come automatically. All right, let's go back to the PPT. Yeah. So now, now what we say, what now we learned about machine learning. What exactly is artificial intelligence? So, artificial intelligence is, as the name suggests, is artificial, and it does not have a human being behind it. So it has to be replicated in that way. So there could be a chatbot or a script that will classify some data, some huge chunks of data into something meaningful. So let us say that if I have to, like for example, what we have said that there are movie star rating. So let's say that I have movie reviews on IMDb, all the text of all the movies since let's say 1990. So that's like a huge, set of data, and I will predict on reading that particular, text and identify how much the star rating should be, like 5 or 4 or 3 out of 5 or 2 out of 5, depending on what the text is. So that's what an AI would do. What I can do is I can take all the list of training data. So let's say that from 1990 I took from 2018, and now from 2019 till 2020, let's say whatever movie reviews I get, I will take that data and run it in my AI agent, which will predict, how much the rating should be. All right, but there are more things that people have used AI in. There is also, the finance companies that they use to identify, predict the outcome of the World Cup of football. They said Belgium would win it, but France won it. So, but it's not absolutely 100% accurate, but it's going in the right direction. All right, so let's come to the semantics of data science. So when we say AI, this is about how the stairway will be to data science, where you have to just fetch the data. First of all, it's just I said that movie data from 1990 to 2018, and you perform your analysis. When I say perform your analysis, you have to identify that there is only text in those fields and not any special characters or any different language. If you're using English, well, let's hope that it's when you perform the analysis that it should only be English. And when you talk about cleansing, so you remove these top words like the, for, to, and, because this is not adding any meaning to the data. And then when I say prepare data for training, then you actually tokenize the data. So when I say the quick fox jumped over the brown dog, so that data in this statement, the words can be removed, and only the quick fox and jump and dog could be used to perform the training. Where because these these words are the the major heart of the meaning of the sentence. Then we perform the training. That is this just you saw that model.fit method was called, where you can use machine learning algorithms and you can predict. Now when we say predict or classify, so you can also split your data. So if I have like 100 rows of data to perform my machine learning, I can say I can use 80% of data to train it and the rest 20% to test it. So the test within that data set that I have, and then I will perform data visualization. I'll see through the maps and the graphs if my accuracy is decent enough, or if it's not decent enough, is it less than 0.5 or zero point 0.6, then I'll have to perform more uh, cleansing of the data and see what all features I have to use, and then eventually then you obviously get a clearer picture on what exactly you want to do and what domain you want to do. It could be anything, healthcare or finance or insurance or sports, anything it could be anything. Okay, ML is now, so since we talk about the prediction techniques, these are the algorithms that you might have heard of or you might be learning about if you have to perform machine learning. This is decision tree classifier, naive Bayes classification, where just that if you have like a list of data is there that is of patients, and you have to classify them if they are diabetic or not diabetic. So depending on their age, their sex, and their eating habits, or their exercising schedule, or their their age. Yeah, I think I already said that. Yeah, so use that data and to classify them into uh, true or false. Like true would be diabetic, false would be not diabetic. So these classifier algorithms can be used in those scenarios. Now, when we say K means clustering and K nearest neighbors, that is done when you have too many categories to, categorize your data. So let us say that if I have incident management and I have different incidents like user access or integration issue or a server issue or the network issue. So those four categories can be used to classify the data set that we have. That would, you know in a nutshell, would come under the umbrella of clustering. Sequence to sequence model is basically used for natural language processing. I will not dig deep into it because it's like a very basic video overview of AI in machine learning. And linear regression, as the name goes, it's similar to what I explained earlier during the video. With the graph that you have, the more regression you perform, it's just a linear equation. So it will help you adjust your line, that graph line that I was talking about. So these are major algorithms that you can see it. You can actually see all of it in this particular link here, which says top 10 algorithms by kdnuggets.com. You can see all the descriptions very nicely put and described here. You can see all of them, logic, logistic regression, and the visualization as well. All right. Now moving on. Now you can see how AI has been trying to change our life. So I think most of us know how the Netflix recommends what else to watch or what is the next show that you should be watching. And then we have the major broader category of AI, where the major tech companies that own the vast majority of the data, like Amazon and Apple and Google. So they have come up with these agents. I think everybody has heard of Siri, Alexa, and Google Home. So they come into the category of horizontal AI. When I say horizontal AI, I mean that something that is global to all fields of AI. So Siri can answer you about the weather. Siri can answer you about the sports game that's going to come up next week, or any news, any celebrity, any movies. It can tell you about everything that you can ask it. But when we design AI, so we have to be very specific to a field or a domain. So that would come under vertical AI. So when I talk about predicting a patient if it's diabetic or not, that comes under vertical AI. Okay, there's a misspelling. I'm sorry. There's a chatbot called woebot, WOEBOT, and replika.ai that you can see. It actually talks to you and tries to understand what you're saying and tries to empathize with you. So this is all AI bots. There is no human interaction there. This is not Eliza, that chatbot, that famous chatbot, but these are like more advanced chatbots that have been created using AI. You can use these list of resources. Fast.ai, also a very good learning material, would be presented by Siraj Raval on YouTube channel. He has his own YouTube channel, and he has this AI school of AI initiative that has been deployed all over the world. So people are getting into these classes and training themselves. As well as medium.com, you'll find more articles and analytics with the more clearer picture into the data science. All right, that's all. That's it. That's all I have. So happy learning. Let me know what you feel, let me know what you think in the comment section below, or write to me if you need more details or suggest anything great, anything worthwhile, anything that I missed out, anything you think is useful for the common public. Thank you.